Here we are in the large floodplains of the world. Large rivers often meander through the plains and once in a while experiencing major floods. A world of great historical importance. Some of the earliest civilizations developed along rivers, such as the Euphrates and the Nile. Having left the steep mountain valleys and having dumped sediments in building alluvial fans, rivers entered now gently sloping regions, forming braided river systems and eventually start meandering in large alluvial plains. Meanders are bends in the river course which form from small irregularities and progressively grow until the neck between the two meanders is broken and an oxbow lake detached from the main river is formed. The process controlling such migration is the lateral variation in river velocity, which is higher on the external side of the meander and low in the inner side. As a consequence of these changes, the river erodes the outer sides of the meander and deposits sands in the inner part, resulting in an outer migration of the meander. You can see the main components of the meandering system in this beautiful picture. In the slide, you see a good overview of the processes taking place in the vertical dimensions within the river. In the external parts of the meander, water has high flow velocities and is therefore able to erode significant amount of sediments. These sediments are transported and then deposited in the internal part of the following curve, where flow velocity and therefore carrying capacity are low. In a vertical section through the meander, you can see the effects. On the right-hand side, you can see the sediments being eroded. On the left-hand side, sediments are being deposited with beds inclined towards the riverbed. Sedimentary successions associated with meandering rivers are characterized by large bodies of sands within finer grained and more regular floodplain succession. The internal structure of the sand is characterized by faucets, which are non-horizontal layers dipping towards the deeper part of the former riverbed. Because of their high sand content and associated high porosity and permeability, meandering river deposits are very interesting targets for water and hydrocarbon exploration. The challenge is, however, to predict their spatial distribution, as they are generally surrounded by finer grained, less permeable deposits. Once in a while, major floods occur. These are typically associated with increased precipitation in the mountains and possibly with difficulty in discharging waters to the sea. Floodplains are typically far away from the mountains, and the increased water volumes generated by high precipitation in the mountains arrive with a significant delay, but also last strong and last longer in the order of weeks. The magnitude or frequency of floods vary, but interesting enough, when plotted together on a logarithmic scale, fall along a straight line, which implies a strong correlation between the numerous small events and the few large ones. These curves are of crucial importance to estimate strength of river protection intervention. And here you see what happens during and after the flood. As valleys in the large plains have low depths, river level will rise with the flood, and waters will pass river banks and invade the floodplains. As soon as the waters get out of the riverbed, the flow velocity will dramatically decrease, and the sandy sediments they were carrying are dumped, forming natural dikes, which we call levees. Waters will then invade the large plains, but only carry the very fine-grained, silt to fine-grained sized sediments typical of floodplains. Once water discharge goes back to normal, waters in the plains will gradually infiltrate the ground and or evaporate, and the river will retain its normal flow. This is what floodplain deposits look like in the field: a regular succession of fine-grained sediments with horizontal and plane parallel overall stratification. You do not need to look very careful to detect a clear cyclic pattern with whitish layer regularly alternated with more reddish ones. There can be several reasons controlling these changes. A typical possibility is that of whitish layers corresponding to periods of erosion where coarser grains are sedimented. The bundles of more sandy layers can correspond to periods of increased flood intensity and magnitude. All these are climatic signals. And now we are at the end of the journey of the river, which formed as a small creek in the mountains and has now reached the coast. During this journey, sediments have been produced by erosion, transported and deposited. And as we have already mentioned in previous movies, the way these sediments are organized, that is, the facies, depends on the physical processes in the site of deposition. Their thickness, on the contrary, depends on the amount of substance affecting the same area. Floodplain deposits can be in places hundreds of meters thick.